Okay, hopefully you are here because you passed the potential energy quiz, and now you're getting ready to tackle the kinetic energy quiz. If you are here because you want help with manipulating the equation, in other words, you want to get the m or the v isolated or just solve for Ke, I am going to do solving for Ke in this video, but I'm not going to do any of this other stuff here. That is another video. So let's start with this graph that I got from cyberphysics.co.uk. This graph, I noticed two things right off the bat. I noticed that there's these blue bars that kind of follow a line, and there's these red bars that follow this curve. So what am I looking at here? You're driving along at 20 miles per hour, and this is your stopping distances. If you're driving along at 20 miles per hour, it's going to take you 12 meters to stop. Or if you want to go American, you say 40 feet. But what if you double your speed to 40 miles per hour? Well, that's going to take you 24 meters to stop. 6 and 24. All I did was I doubled my speed, yet my stopping distance quadrupled. Why in the heck does that happen? So right here, I'm just looking at these red bars. The blue bars right here, what are they all about? That's about your reaction time. It's tied in with something that these people call your thinking distance. And that's just this equation right here. Distance is speed times time. Your reaction time is what it is, and the faster you're going, the higher your speed, the greater the distance it takes you to stop. So there's no exponents in this equation. This is just a linear equation, so the blue bars make this line. The red bars, though, they follow a different relationship. There is an exponent here, so they make this curve. And that's what I wanted to talk about. So I took this image and I rotated it so it looked like a graph that my kids are probably more accustomed to. And I figured 0 would be about here. And here's the distance you go just with your reaction time. And here is the distance you go once you actually hit the brakes and your car is stopping. So this is kind of weird. This curve here shows us that in the equation, velocity, since it's squared, that's kind of a big deal. And the mass is important too, don't get me wrong, but the velocity in my mind is much more important. So I'm going to mess with the equation. So what I did was I made myself a table and I asked myself 3 questions. What happens if either m or v is 0? What happens if I double or half my mass? And what happens if I double or halve my velocity? Looks like I lost some of my letters here. Okay, so I stuck those letters back in, and let's just start with this one. What happens if either m or v is 0? So if I put in, let's start with m is 0, and my velocity is 1. So my equation, m times v squared, 1 squared is 1 times 0 is 0, so I wind up with no kinetic energy. And I'm not going to bother putting joules here. I'm more interested in just thinking about the equation, not about the units right now. So what happens if instead my velocity is 0? So this time I'll put a 1 for mass just to use easy numbers and a 0 for velocity. So this time I've got, instead of 0 times 1, I've got 1 times 0 squared. So if I square, yeah, this is just 0 again. So this one, if either m or v is 0, if the object is not moving, then it has 0 joules of kinetic energy. All right, so check. That one's off my list. Now let's mess around with these other 2 questions. Before I do that, I think I'm going to give myself a basic situation. I'm going to say that I've got a mass of 1 and a velocity of 1. That'll get me an answer, and then I can think about these 2 things. So if I plug in a 1 for each of these 2 things, mass and velocity, I get 1 times 1 squared, that's 1 over 2. I get 0.5 joules of kinetic energy. All right, so now I'm going to use this to think about these 2 situations. I'm going to double or half my mass. So I'm going to leave my velocity 1, because I don't want to change 2 things at a time. I won't know which one makes the difference. So if I double my mass, I'm going to put a 2 here. So I've got a 2 for my mass, and since I'm leaving my velocity the same, a 1 for v. So 1 squared is 1 times 2 is 2. Divided by 2 is 1. just as a side note here, hopefully not distracting you too much, I do see some kids do this first and then square it. They're not following PEMDAS. Remember, PEMDAS says that you've got to do your exponents first, so you've got to square this v before you multiply it by your mass. But anyway, going back, if I double my mass, if I go from 1 to 2, and I leave my velocity the same, my kinetic energy went from 0.5 to 1. In other words, if I doubled it, then I double my kinetic energy. And likewise, what if I go from a mass of 2 down to a mass of 1? Well, then I go from a kinetic energy of 1 down to a kinetic energy of 0.5. So I either double or halve my kinetic energy. So that's that linear relationship. Now let's mess with the velocity. So I guess I'll leave this stuff here just so I know it was there, but I'm gonna maybe I'll get rid of it. Yeah, I got rid of it so it wouldn't distract me. So now I'm gonna double my velocity. So I'm gonna leave my mass at 1, and then I'm gonna take my velocity of 1, and instead of having that, I'm gonna put in a 2. So up in my equation here, I've got a mass of 1 and a velocity of 2. So I've got 1 times 2 squared. 2 squared is 4, times 1 is 4, divided by 2 is 2. That is definitely different. This is not the double or halve relationship that we had with mass. This is something else. What we've got now is we've got 0.5 up to 2. Well, how many times does 0.5 go into 2? That is a change of 4 times. That's significant. So if we double our velocity, then we quadruple our kinetic energy. Likewise, if we took our velocity from 2 back down to 1, our kinetic energy would go from 2 down to 0.5. So that would be quartering. So if you cut your velocity in half, or you halve your velocity, you quarter your kinetic energy. So that explains why the graph looks like it looks. These red lines get longer with an exponential kind of a growth curve. And there is my video on the kinetic energy equation.